Hello, and welcome to this pre-recorded event for feedback on June 2015 AEA Mathematics. To help you get the most out of this feedback, you may want to have the following documents handy, as we will refer to them during the session. The question paper, so that you can view the questions. The mark scheme. You will use this in Activity 2. The Principal Examiner's Report, although the main points are quoted in this presentation. The Activity 1 file, a set of tasks which should illuminate aspects of the paper. The Activity 1 Responses file, which contains ideas which go with Activity 1. The Activity 2 file, which contains examples of students' work. The Activity 2 Responses file, which contains the agreed marks. The aims and objectives of this presentation are to receive feedback on national performance of candidates in the AEA exam of June 2015, to consider the variation of candidates' performance on different questions, and possible reasons for this, to look at extracts from the Principal Examiner's Report, to share best teaching practice. Here are some opening extracts from the Principal Examiner's Report. Many students were able to demonstrate competence in problem solving on this paper. However, many found questions 3, 4c, and 7b and 7c a severe challenge. More on these later. Question 1. Most candidates were able to score marks on both parts. However, in some cases the asymptote was not labelled correctly. The graph shown scores only 2 of the 3 available marks. Question 2. Most candidates were able to score 6 of the 9 marks available. Typically, this was done by squaring both sides, rearranging and squaring again to get a cubic equation. This could be easily solved by factorization. However, only a few realized that squaring may have introduced extra solutions, and suitable checks were only carried out by the better students. This is a key teaching point. This student has been taught to check solutions, so gaining an additional 3 marks. Question 3 proved to be very challenging. Many candidates were unable to score any marks. This was because some vision was required to see that the left-hand side terms could be combined. Students then had to see that the sec x on the right-hand side could be cancelled away once the sin 2x term had been expanded. A second challenge was to solve the equation cosine of 2x plus 78 degrees equals sin x. Good students tended to approach it in the way shown here, although only the most able managed to find all 4 solutions in the range 0 to 360 degrees. At this stage, you might want to mark the 5 examples of students' work on question 3. The marks actually awarded are given in the response file. Question 4. Competent candidates were able to score marks on parts A, B, and D. For this level of candidate, Part A was straightforward. Here is a typical competent response. And Part B was generally well done, as it was a routine development of Part A. The work shown was typical. Some candidates factorized the given expression first, used Part A, and then multiplied out the two separate expansions. We shall look at Part C in a moment. Part D was a development of Part B, requiring term-by-term integration. Good candidates saw that the even-powered terms were not going to contribute to the final answer, and saved themselves some work. This is especially important in a non-calculator examination, such as AEA. As stated earlier, it was Part C which caused the most difficulty. For some candidates, the problem was either not knowing the conditions for convergence of a binomial expansion, or failing to see how these could be used to establish the required result. Successful candidates knew that condition, and also how to approach showing the required result. This slide shows one possible approach, and the next slide a second. This approach uses the graph of y is congruent to modulo 5x plus x squared and looks at its value in the interval minus 0.5, 0.5. The blue line is y equals 4. So it is clear that the value of modulo 5x plus x squared is less than 4. Tucked away at the bottom of the screen is the comment that another approach involves the factorization of 4 plus 5x plus x squared as 4 plus x multiplied by 1 plus x, and then looking at the convergence of the two terms in the expansion of 4 plus x to the power of 1 over 2 by 1 plus x to the power of 1 over 2. In summary, students tended to perform well in A, B, and D. Most candidates showed an understanding of familiar techniques. Part C could be improved by considering simple conditions for convergence of the binomial. Question 5, parts A and B, were answered very well by the majority. Part D was well answered by some, but many failed to see that they could use the quadratic formula. The solution shown here is a good one, with the correct sign being chosen before the square root. Part C, the graph, D, and E are closely linked. The graph shows that there is only one root. This must lie on the line y equals x, so the most efficient way of answering part E was to solve the equation g as a function of x equals x. This was not apparent to some able students, so is a teaching point that should be considered. In contrast, some candidates were very poor at drawing the graph. They tended to do badly on subsequent parts. Although this was a long question, the structure meant that all the students could make some progress here. Part A was answered very well, using a scalar product, and most could answer B by showing that the three equations in mu and lambda were inconsistent. In Part C, most students wrote vector AX in terms of lambda, and then used a suitable scalar product to obtain a linear equation in lambda, which was easily solved. In Part E, the most common approach was to write vector Bx in terms of mu, then form and equate moduli to form a quadratic equation in mu. However, even at this level of sophistication, there were candidates who wrote mu equals 3/4, and such careless errors were not that unusual. As shown on this slide, depending on where these occurred, some candidates lost all subsequent accuracy marks, so it could be an expensive error. Another loss of marks came about because it was apparent that some candidates did not know the word skew, and so did not attempt Part B. In conclusion for this long question, students who tended to perform well showed accurate working when carrying out complex algebraic manipulation, understood the vocabulary of the situation, were able to translate geometrical statements into algebraic equations. Question 7 was very long, with 3 substantial parts. Many candidates made a good start with Part A. This candidate has converted to sines and cosine in the integral. Others spotted cosec x cot x and were able to integrate directly. As on this slide. In Part B, the instruction to integrate by parts helped many get started, but some chose to integrate cosec theta and were rarely able to complete the integration. This student has followed the instruction to integrate by parts and shows a level of mathematical sophistication. However, many ran into difficulty. For Part C, most were able to identify a correct integral, and many tried the same substitution as in A, and got as far as the integral of cosec theta cot to the 4th theta d theta. The strategy required then was similar to Part B, where an equation in K equals the integral of cosec theta cot to the 4th theta d theta was to be sought. On this question, successful candidates were able to apply the substitution given in Part A accurately, were able to use integration by parts to form an equation in the given integral in Part B, were able to apply the ideas they used in Part B to complete Part C. Activity or Task 2 raises some points of interest in the light of responses to some of the exam questions on the paper. The Activity 2 response file contains some partial answers and outline solutions. This slide gives some information about the statistics available to teachers. This slide gives some information about developments in GCSE and GCE. The AEA examination will be available in 2016 and 2017. We hope to produce a successor examination to be available in 2018. Thank you. We constantly look to improve the training we provide. Please let us know what you thought of the training by completing our online feedback form.